Hi, this is Chong Kim, and this is Ruby Chess Part 4. Okay, let's see where we left off. Okay, we have an ambiguous move here, and the move is rook e1. And rook e1 is right here, and there's one rook here, and there's another rook here. It's ambiguous in the sense that both of them can move there, but it's not really ambiguous because this rook is pinned. This queen has the rook pinned, and if this rook moved, then it would leave the white king in check. So that's what we're going to do. Is we're going to make a check in the code. So okay. No tag file. So let's create the tag file. Okay, so now let's go to move. Okay, so here we have this, and the code is over here. I'm not really happy with the way this code is, and eventually once we make everything pass, I'll refactor this. Okay, so the problem is that the error is happening over here, the ambiguous move. And so what should have happened is during the selection process, it should have eliminated that move as a possibility because that would lead to an illegal state. So we should put something in here, right here, and let me just separate this a little bit. So we're going to put something in here to filter out the if you're in check. So let's do that. So select index where, and what we're going to do here is create a temporary variable which is a duplicate position, and we're going to make the move for each of those. So temp move the piece from the IDX to the target IDX. Okay, and we're going to see if in check, if you're in check. And all right, so let's see. And undefined in check, so we will create in check. And we'll do it right before move. So, okay, so right here, we'll do in check. So if we have a position where we set it up and we say, is this in check? Is the king in check? Are you in check? So it's white to move and is saying, is white in check? And the answer is false. But if we have another position where we have a king on e4 and a black pawn on f5, then the king is in check, so in check should return true, so it should be true. Okay, so let's see if we can make this pass. All right, so undefined method in check, so we'll create the in check function. Okay, and the way that we're going to determine if the king is in check is we're going to say, well, first we have to find the king's position. So, well, I'm going to set this to nil first, and we're going to go through all the indices and look for, okay, we're going to look for the king. So find, and it's going to be depending on whose turn it is. If it's white's turn, we are looking for a capital K. Otherwise, we're looking for a lowercase k. And we're going to find something for the target destination, which is the IDX. Actually, find the king. All right. Um, so we're looking for the king. Actually, this is completely wrong. We don't need to do this because this is for king movement. And we're just finding the king, so we're just looking at the piece. So board idx is equal to king. Okay, this is right. Okay, so at this point, actually this would be if. So we found the king, and so we'll just set the king index to be that. Okay, so at this point, if the king did exist, then let's see if we need to find out if you're in check. So the way that we'll do that is by going through all the pieces. So actually, the pieces are rook, knight, bishop, queen, king. Oh, and a pawn. So these are all the possible pieces, and we're gonna either upcase or downcase them. So if it's white's turn, we want to downcase because we're looking for black pieces. Otherwise, upcase. Okay. So then, for each of those, we're going to be looking for if any of these situations happen. So we're looking for the opponent piece. So this is the opponent piece. I'll just say opponent piece. I'll just spell it out. Opponent piece. And we're looking to see if that will attack our king. And so the way that we'll do that is by saying find the opponent piece that's able to go to the king square, the king index. And that should be non-empty. So, all right, so it should not be empty. So if any of these pieces are able to hit the king, then you are in check. Okay, so we'll try this out. Okay, and it failed the first test. And it says, oh, well, it's, okay, the spec is line 100, but I know why this is happening. The reason is because of find. When we defined find, we were expecting that the piece that you're looking for is your own piece, but this time we're looking at the opponent's. So the definition of find is actually different. So let's go take a look at how the tests are written. Okay, so let's look for find. Okay, here's find. So in these cases, so you have these situations where it's white's turn and you're looking for a white rook. And so it's always the same color as whose turn it is. But this time it's different. So I'm going to add a test here. So actually, I'll take this one, for example. And there's a pawn on e4 and there's a pawn on g6. So I'm going to say find a black pawn that can go to g5. Okay. And that should be equal to g6. Okay. So, all right, so let's see. All right, so we see that it failed, and so we need to make find pass. Okay, so let's go to find, and this is where it's doing the test for white. Actually, let's see if we have a white. Okay, so we don't have any tests for white. And so I'm actually going to delete delete white here because I'm going to modify the way this is done because this function is dependent on the turn. Instead, I want it to be passed in. And because it's passed in, it's not dependent on the position at all. So I'm going to move that into here, into the chess helper. So it'll take some kind of indicator. I'll just say piece and black-white value. So we want to have the same behavior as before. So if case piece, okay, when it's a capital letter, A through Z, or if it's white, then we just want to return the white value. When it's a lowercase letter, A through Z, then we want it to be black, or black, then we want it to return the black value. Otherwise, it's going to just return nil. Okay, so this should handle that situation. So wrong number of arguments, 2 for 3 for white, chess 24. So 24 is right here. Chess, oh, this is a spec. 24 is right here. Okay, so, okay, okay, so here, what we want to do is we want to send in the piece. So this would be the source piece, and I don't think I have source piece at all. Actually, I'm using it over here, so I might as well create source piece. Okay, and then I could just use it over here. I would say source piece. Okay. And actually, it really doesn't matter because once I'm in this part of the code, the source piece and the piece is the same. So I could have just used piece. So I'll just use piece. Okay, so depending on the piece, it'll do that, and do that over here as well. So piece, and there's another one over there. Okay. Okay. Okay, so for this, this is en passant piece. So I'll just make that piece as well. And in check, that is dependent on, well, there's no piece involved here because we're trying to figure out the piece, but that's based on whose turn it is. So I'll just put turn for this one. In this case, it is also based on the turn. See, this one, send upcase or downcase. Okay, so this is also dependent on the turn. Okay, next, upcase, downcase, dependent on the turn. Okay, castle, you're trying to figure out what piece it is, so that's also based on a turn. And same thing over here. And for all these as well. All right, some more. Okay, so long castle also turn. Okay, the last one, turn. So this one obviously based on turn as well. Okay. Okay, so the first one is an illegal move. All right, so let's see why this is failing. E4, it's failing on handle move piece 147. Okay, so let's go to 147. Okay, illegal if the list is empty. So the list is empty. So let's figure out what's happening here. We can trigger the debugger, and it's probably, this is like new code over here, so that's probably why it's failing. I'll put a debugger statement here first. Okay, so let's take a look at the list. So there is something in the list, and okay, so this is the original position, and let's step through. Temp, move piece. Now let's take a look at what temp looks like. Okay, so that's what we expect, and temp in check should return false. So let's step through, and in check. Okay, so we should have a king position. Okay, and it's 60, and if we convert that to a square, that's E1, which is correct. So now for all those pieces, it's gonna either downcase or upcase, and it should downcase. So just step through, and let's take a look at the opponent piece. It's lowercase r. Okay, so far so good. And oh, not empty. So let's see for find opponent. Actually, let's do a display, because I want to breakpoint at 131, and each time we're going to display the find opponent piece king index, and let's see what that is. Okay, so that's empty, and we could see the value over here. Okay, and it's empty again, that's good. Let's also display the opponent piece. Okay, it's knight, and now we're looking at the bishop, queen, king, and pawn. So far everything has been empty. So what we should end up is it should be all false. So this whole thing should return false. That's what I expect. But it's empty. And that's actually really strange. So this is not what I expected. We save, and let's just step through, and okay, so after it makes the move, I'm going to just say in check, and this should return false, which is correct. False. B145. Okay, so oh, I see. I have the logic completely wrong. So you want to select those that are not in check. So it's not in check. All right. Okay, so we're past the ambiguous move point. So it's able to handle that situation now. Okay, so handle move piece, illegal move, rook c7. Let's see why rook c7. But before we do that, let's take a look at how much progress we've made. We'll run the Rspec, and we can see that it's made its way all the way up to game 31. So that's pretty good. So about 30 games, and and it's been passing all those. So rook c7. Let's see what's wrong with rook c7. This, whose turn is it to move? Let's see. Actually, here they don't say whose turn it is. So queen b8. This is after you've made queen b8. So b8 is black, so black just moved. And rook c7. Let's try and do rook c7 for white. Yes, rook c7 is this rook to c7. And obviously there's a pawn in the way. So let's backtrack in this game to see where it went wrong. So game 31. So I'm going to Rspec less and look for game 31. Okay. All right. So I'm looking at the very one of these things, and you can, as I step through, you can see it almost animating. And at a certain point, I'm probably sure it's probably an en passant. So I'm looking at this pawn to see when this pawn should disappear. And this pawn should disappear. Okay, so that just made a move. And okay, I see what happened here. So there's this pawn here, and it took this pawn en passant. So d takes c6, d takes c6, but this pawn is still there. So there is a problem with that. So we need to make a test. We need to modify the see, making the move. I wonder if there's a move piece here. Okay, there's no move piece. Move piece, move. Okay, we do have the move piece, but we don't handle the situation of en passant. So we have the en passant square, but we don't actually handle the case that if it is en passant, we also remove the en passant. So we do have the move piece, but we don't actually, we should actually handle the en passant over here. And we do, okay, so right now, in our test, we do have a test for it, but it's caught up in the file. And it's not quite obvious. So if this file ever goes away, then we want to have a record of what we're trying to do. So I want to make sure that it also handles en passant specifically. So I'll just put a context and say en passant. Okay, and we'll set up a position where we have an en passant situation. We'll have a pawn on e2, e4, a pawn on f4, black pawn, f4, and the en passant square, actually, I'll just say r5 and, okay, f5. And I'll say that the en passant square is f6. Okay, and it's white's turn. I feel like this should have been handled somewhere. And okay, so we have find. So we're able to find the piece. Oh, I see. So we're not actually, we're good at finding it, but not actually executing it. Okay, so that's where the logic kind of fell apart. Yeah, I don't like the organization of this, so I can't wait until I make everything pass so that I could refactor this. Because I think it's also the logic of the code is starting to get a little bit long as well. Okay, so we have the situation here where we have a position, en passant square, and we make the move e takes f6. So it takes the en passant square. So it should be able to find it, and now I could write some tests saying that the subject f6 square should be the pawn, our white pawn, and it should expect the subject's e5 square, not e5, f5 square. That's the opponent's pawn, and that should be empty. So that should be taken away. So okay, so great. We see that the en passant is not being handled. So now we can make it handled. Um, so here we move the piece, and we have to check if it's en passant. So we could say the target index. Yeah, we have the target index, and let's compare that to square of that. Compare that to the en passant. So if this is true, then we also want to take the en passant square, 2 idx of the en passant square, and set that equal to a blank. Okay, so let's see if it passes. Okay, so undefined local variable f6. Let's see. Why does it think? Oh, the tests. Oh, here it is. Okay. So let's. Okay, that should be that simple f6. Okay, so undefined bracket for nil class. That's very interesting. So oh, because there's no king. Okay, right. I'm going to modify in check. So in check. So if it doesn't have a king, actually I'll make it as part of the in check. Actually in check function, so that so if I don't have, I'll just say new. So it doesn't have anything, and I'll say in check, and I'll say false, be false, instead of throwing an error. All right, so new in check. Okay, so we get an error instead, so that's great. So we're here, and so we only want to do this if in check. So only if it exists. So let's see what happens. So if it's nil, then this will be nil, and it'll just all be false. So are you in check? Well, if there is a king position, if there is a king, and there's something attacking it, that's basically what this is saying. All right. All right. So we have this error about the en passant still. Oh, actually, no. This is actually correct. It looks like. So expect f6. Oh, f6. All right. So where is the test? 149. Okay. It looks like the test is wrong. So 149. So 149. Okay. Oh, right. So this is actually correct. The test is correct. The code is incorrect. So it's calling move here, and move is calling handle move piece, and the en passant situation is right here. So this, okay, so the test is correct, but it's not the opposite. The en passant square is not the one where it should disappear. It's the okay. So let's create a little grid over here just to clarify how things should, okay, what we're doing here. Okay, so we have a pawn on a square, capital P, and we have a lowercase p. It's kind of hard to see, so I'll just put A for like pawn, the second letter of pawn. So we have a pawn here and a pawn there, and we're trying to go, so what we're doing is we're moving the piece here, and we take this out. So we need to take this one out. And so this was the source, this is the target, and this one we don't have any name associated with this, but it is a space away from, a row away from the target. So it is actually, so the target is correct, and depending on whose turn it is, white and the piece, actually you're actually making a move. So based on the turn, so if it's white's turn, actually let's do it based on the piece. So if the piece is a white piece, then we want to add 8 to it. Actually, you don't want to do minus, we want to do plus. Okay. And subtract 8, minus 8 if it's black. Okay. So let's, oh, actually I did this in the wrong area. Okay, so I was supposed to do it right here. So it is plus white based on a turn. It's going to be, if it's white, then it's going to be 8, otherwise minus 8. Okay. All right, so that looks good. All right, uninitialized constant P, 151. Oh, that's right. All right. All right, so we were at 31, and now it's at 32. So we made some progress. So this is an interesting position here because this is using a specifier that we handled the case where we put a file here, but now this is the rank. Okay, great. So we know exactly what to do. We do the same thing as before. Okay, we go back to the here. All right. So we handled the situation where we have the column, but we should also say question mark and mark this with column and row. And the row would have 1 through 8 and with a question mark because it may not be there. So, and we're going to use that as a filter. So there should be a filter here somewhere. Oh, here's the filter. So I'm going to duplicate this code, and this time select if the row is specified row, and the row is going to be 0 through 1. So 2 row of the index, and 2 row again, and row. Okay. Okay, so it doesn't know about 2 row. That's quite interesting. All right, right, because, all right, 2 row. Okay, so we need to write something for 2 row just the same way. So we have 2 column over here, and we can just copy this and just do the same thing for row. Okay, and it'll be a 1 and a 2. So this should equal row, the first row should be, let's see, 8, row 8. Okay, and let's see, that should be row 7. Row, and if it's a number, it should, okay, this is the index position. If the index is 0, then it should be 0. If the index is 1, that should still be 0. And for 8, that should be a 1, because 8 would be the next row. Okay. Okay, undefined method to row. Okay, so now let's write to row. We have two column over here, so we'll create to row index, and so we do the conversion here, so it's actually 8 or minus interesting. It's interesting because we're using to row and to column, and I'm taking a look at to index, and well, okay, I'll fix up to index. Okay, so all right, if is a string. Okay, and then you can say divide by 8. Okay, so this should handle this situation. Expected 8 got 0. Row with 1. Oh, right. Oh, this is really interesting. Right. Okay. So wow. Okay. So the way the board looks like is 1, 2, 3, 4, and so on. And this should map to 0. This should map to 1. But the way the board is written, actually this is wrong, because the way the board is written is like this, and so on. So the top one would be an 8, and that should become a 0. So if it's a string, and let's say the string says it's 8, so the 8 actually, what is the test failing with? Actually, this is not going to compile. Just comment this out. Okay. Okay, what it's saying is expecting 8, so 1. 1 should be all the way at the bottom. All right, so let's take a look at 1. Okay, so 1, eight minus 1. Oh, of course. Of course. The reason why this works is because this is a number between 0 and 7. And this is a number between 0 and 7. So this index would remain unchanged. So really, the logic of this is actually incorrect. It should really be like this. If it's a string, then return this. Otherwise, return this. So this is what it should be. And it's actually better written like this. Okay, and we could do the same thing here. All right. So this should work. Okay, close. Oh, that is right. The test is incorrect because when it's 1, it should be 7 and 6 because it goes from 0 through 8, 0 through 7. So the highest number is a 7. So that should be right. And if it's okay, so all this should be right. Okay. So let's see where it's failing now. Let's see how far we've gotten. I think the last time we got to 32 and 36. Okay, ambiguous move, D4. Okay, so let's see. Well, let's take a look at the position. D4. So you have, it's hard to say whose turn it is. So let's take a look at this. The last successful was D takes E4. So this is the E4 square, and that looks like it's a lowercase p. And the move is D4. So there's a pawn that can go to D4, and this one, there's only one pawn that can go to D4, but it's probably thinking, I'm guessing that it's confused with this one. So, okay. All right. Let's try D4. I think this is a good stopping point because we made a lot of changes, and I want to take a look at this, but I don't want to keep messing up the position. So let's see how much changes we've made. We made some changes over there. Yeah, we made quite a bit of changes, so I want to commit this. And so I'll see you in the next episode.